Swayam Prabha. Digital India. Educated India.
Out, I want you to work them out. Okay, let's see. All of these are worked out examples of cotton, so you can refer to the book anytime and you can do it. Molecular vibrations, chapter 8, chapter 10. So let's see. Let's say pyramidal AB3. Any example you know? Point group? C3V, very good. Now what do we need to do? I need to work out the symmetries of normal modes. Let us see. C3V. What are the operations? E, how many C3? C3, then 3 sigma V. Okay. Now, to start with, what I will do is I will write the character table for you. This is a small character table I can write. Can you write? The first row at least. 1, minus 1, 1, and column 1, 1, 2, very good. Now fill it in. What do I have? We had worked this out, did we? 1 minus 1 and 2 minus 1, 0. And you know very well that this minus 1 is not equivalent to this minus 1. This minus 1 means a change in sign. This minus 1 is minus half plus minus half. They are mixing. Now, where does x belong? Where does y belong? Where does z belong? First name them. A1, A2, E. Then where z is here. What about x and y? X and y jointly form a basis for E. And I will also tell you that Rx and Ry also jointly form a basis for E, and Rz actually forms a basis for A2. Okay, what we are trying to do now is that we are trying to use the tabular method of working out this problem. This is discussed in Carter's book. It is a little neater method than doing it line by line. Okay. In physical chemistry, you should learn to construct nice tables, and that helps you in many places. Like for example, trying to work out how many people will move from which hostel so that everybody in the 4th year gets single room. Tables help a lot. Seriously, now the thing is, we have these tables that help us, and we have actual tables made of wood that do not help us because they do not come in time. Both are there. Now, what will I do? What will I do? I want to construct your gamma wave. How do I construct gamma wave? Remember that formula for chi r? What is it? Chi of r for gamma wave How do you write it? Chi VIB R is equal to n minus 1 chi xyz R, then minus chi. So, I will just write chi dot R because I am running out of paper. So, instead of trying to write gamma VIB first, what we can do is we can do it in steps. What is your gamma xyz? Write that. Gamma xyz, what will it be? Tell me quickly. 4, 3, 0, 1. या समझे या नहीं समझे? समझ गया ना? अच्छा, gamma xyz. Next, I'll write gamma rx, ry, rz. What is that? 3, 0, minus 1. I am adding E with A2, isn't it? Alright. So, now what do I want now? I will write N also, just to be a little more methodical. N for this. Okay, don't forget how many atoms are there. How many atoms are there? 4. How many atoms change place under identity operation? 0. So, this is 0, 4. Number of atoms that do not change places, 4. How many atoms do not change places upon operation of C3? 1. Very good. What about sigma V? 2. Sure? Not 3? Not 3? Okay. 2 atoms and a ghost atom. If it is ammonia, for example, that lone pair is called a ghost atom, but we do not consider ghosts. So, this is 0, sigma V 2, okay, 4 1 2. Now, it has become a little simple, isn't it? Now, what I want is I want gamma VIB. Can you do it quickly? N minus 1 multiplied by chi xyz r minus chi dot r. 3 multiplied by 3, 9, minus 4, 5, minus 3, 9 minus 3 is 6, it is not 9 minus 4, oh, fine, 6. Achha, how many normal modes should it be? How many normal modes should I have here? 3n minus 6, what is n here? N in the sense, what is the number of atoms? 4. So, 3 into 4 minus 6 is 6. It is the same as BF3, same as D3H. Okay, it is just that that was a planar molecule, this is a non-planar molecule, but they are not linear molecules. If it is linear molecule, then only it will be 3n minus 5. So, 6. So, this is correct then, isn't it? Dimensionality. I have only 2 more to work out. So, 1 minus 1 is 0 anyway, 0 multiplied by 0 is 0 definitely, 0 multiplied by 0 minus 0 is 5, then 0. Then 2 minus 1 is 1, 1 into 1, 1, 1 minus minus 1, 2 or 0, 2, 602. Can you now break it down using AI equal to 1 by H sum over R chi of R chi I of R. What is H? 3. Let us see, 1, n minus 1, 1 multiplied by 1, 1 into 1 is 1, then minus minus 1, alright, right. First tell me what is H, 6, sure, is equal to what plus what plus what? 2A1 plus 2E. Once again, this is a step where we can check whether we have gone wrong somewhere. 2A1 plus 2E. So, what is the dimensionality total? 6, and we are talking about a 6 dimensional basis anyway. So, seems to be right, okay, at least consistent. Fine. Now, what do we need to do? We need to assign the internal motions. What are the internal motions here once again? The bond lengths and the bond angles. What is the difference between then and now? There is no restriction on the thetas, isn't it? They can actually expand at the same time, right? All can expand at the same time. So, A1 is possible, right? So, can you do this now? Gamma r and gamma theta. See, this is a nice way of doing it, isn't it? In one table, you can do it step by step, and it is very easy to find out if you are going wrong or not. So, try to do it this way. Gamma r. Gamma r, now you know what the r's are? Pyramidal, NH3. Huh? What is the character for E? What is the character for C3? C3? What about sigma V? 1? 1, sigma V is 1 because it has to go through 1, 301. Now look at these two, you do not even have to use the thetas, no, because gamma V is 602 and gamma R is 301. 602 minus 301 is 301, isn't it? Right? Gamma wave has to be gamma r plus gamma theta if there is no redundant coordinate. If there is a redundant coordinate, then there is an issue. Okay, and then 602, it is very nice, and this is coming out to be 301. Okay, so but just to satisfy yourself, let us work out the representation using the thetas. So, expansion is plus, contraction is minus, plus minus. What will be the character for E? It will be 3. If you apply C3, then what will happen? The 3 angles will all move. Theta 1 goes to theta 2, theta 2 goes to theta 3, theta 3 goes to theta 1, right? All are rolling stones, and according to Shantanu, they will gather no moss. So, character for them is 0. Okay. What about sigma V? One of the angle remains where it was, isn't it? So, once again the character is 1. 301, 301, you can break it down, they will turn out to be A1 plus E. Now, what does this mean? That means the A1 modes, how many A1 modes are there? 2 A1 modes. They involve bond stretch, they involve stretch as well as bend, isn't it? There should be 2 A1 modes of vibration, you have said, and then these are turning out to be A1 plus E. Each is turning out to be A1 plus E. So, the A1 modes are going to have stretch as well as bend. So, what will the A1 modes look like? So, what I am saying is that now can you think of a symmetric vibration involving stretch as well as a bend? Understand? A1 means totally symmetric, no matter what you do, it is not going to change sign. So, think of a vibration that involves stretch as well as bend and is totally symmetric. No, what I am saying is that see, they have to expand also. Your umbrella does not expand, the spokes of the umbrella remain the same unless it is a folding umbrella. Okay. So, one it can be, it is when the bonds stretch, the angles also increase, that could be one, you can say that when the bonds stretch, the angles also increase. That could be one normal mode. Understand what I am saying? Not only is it going out, your umbrella is opening, but the umbrella is becoming bigger also. It is an umbrella already, okay, but it is opening out and at the same time it is becoming bigger. Let us say that is one. Let us say, let us see if it fits. Yeah? Question? What will be the minus phase? Let me see if I can draw it. So, we are talking about C3V, AB3 kind of molecule. We have already seen that you have A1 plus E, I will write like this, and all the modes involve stretch as well as bend. So, what I am saying is, let us think like this. You have nitrogen, hydrogen, hydrogen, hydrogen going out, and while it is going out, the angles also increase at the same time. I just realized that I cannot draw it. If it is not simple harmonic. See, planar will dome, there is no issue, but a molecule that is already like this, if it has to become planar, then it has to be a very, very major displacement, isn't it? It has to be a very major displacement. That is not about to happen. Now, can you think of linear combinations? That is what I am saying. Linear combinations of stretch and bend, which will also be of A1 symmetry. One thing I can say is, they expand together, right, and also the angles increase together. This is plus. This is maybe a good way of drawing it, isn't it? Right? Let us say this is plus psi. What will be minus psi? The direction of the arrows will reverse. That is what we are arriving at. Okay, this is plus xi, that is minus xi. Is this A1? That is what I am asking. This has to be A1, isn't it? Because the way I have drawn the arrows, there are two sets of arrows, one along the bonds and other perpendicular to the bonds. Okay, let us see. What will be the character of C3 of E? Of course, 3. I am taking this combination of arrow as 1. All right. Now, what will be C3? What will be the character of C3? Now, what we are doing is, we are taking this whole thing as 1, like doming motion. All these 1, 2, 3, 4, 5, 6 arrows, they form one kind of motion. That is what I am saying. Okay. This is plus 1, that is minus 1. If you apply C3 to this, the arrows going up still keep going up, isn't it? If I consider the whole thing to be 1, then arrows going up keep going up, they do not come down. Arrows going out keep going out, they do not come back, right. So, even when you apply C3, character is 1. If you apply sigma v, then what happens? Same thing happens, because this will remain unchanged, these two interchange fine, but the whole thing is considered to be one motion. So, this is A1. Okay. A1 never becomes minus, xi never becomes minus xi. So, next what you could do is simply reverse the direction of these arrows. As I said correctly, what we have is, we have say A1 stretch and we have A1 bend. The possible linear combinations are plus and minus. Understand what I am saying? What I am saying is that you have to have two A1 normal modes, right? That is what we have shown. Now, it is impossible to distinguish between vibration, between stretch and bend here. Since the symmetries are the same, what must be happening is a linear combination. Okay. So, since this all arrows going out together is A1 and all arrows going up together is another A1, first is from the bond length and the second is from the bond angles. When you just add them, you get A1 symmetry. When you subtract one from the other, then also you get A1 symmetry. That means, while stretching, just think of stretching. While stretching, in one case the bond angle increases, bond angles increase. In the other case, while stretching, bond angles decrease. These are the two normal modes of vibration of say NH3 which have A1 symmetry. Okay, what have we got? This is what we have got, right? And what I am saying is that when I break down the reducible representation which I constructed using only the stretch, I get A1 plus E. When I break down the reducible representation that I got from only the bends, then also I get A1 plus E, right. Now, what I am trying to say is E is always more complicated, because if there is mixing of too many things, I do not want to do that now. What I am saying is, can we identify what are the A1 stretch actually? What is the A1 vibrations actually, not stretch? Okay, if I say stretch, it becomes confusing. What are the A1 vibrations? What are the A1 vibrational normal modes? No. So, what I am saying is these are two completely different kinds of vibration. Since they have the same symmetry, they have to mix. They have to mix. You cannot have a pure stretch and a pure bend like that. It has to be a linear combination like this. So, one of them will be angles opening up while the stretching is taking place, the other will be angles closing down when the stretching is taking place. See, these two are not related by plus minus, is not it? They are different. Let us take it like this. Let us first talk about this when stretching takes place. Okay. What we are saying is, in one case the angles are increasing, in the other case the angles are decreasing. The other would be when it is in the opposite phase, then again angles can be opening up or angles can be closing down. So, these are just the negative phases, nothing else. Okay. So, see, for BF3 for NH3 at least, we have been exactly able to tell what are the two normal modes. Stretching and bending have to be together. What is the difference from say BF3? For BF3 we had said that there has to be a pure stretch without any bending motion at all. Here what we are saying is that you cannot have a pure stretch. A stretch has to be accompanied by a bend, at least for the totally symmetric one. The E ones are more complicated, we will not get there, E dash.